Good morning, this is your stats sensei, Mr. Spensei, and this is an exit ticket on Introduction to the T-Distribution. So you receive a brochure from a large university because you're applying for college. The brochure indicates that the mean class size for full-time faculty is 32 students. So the average 32 students per class. That's the claim. When you visit the classes at the university, you have a feeling that the class sizes are much larger than 32. So you think that they're greater than 32. You want to test the university's claim, so you randomly select 18. So we have a sample size of 18. And classes taught by full-time faculty and determine the class size of each. The results are listed in the table below. All right, so we have data. So if we have data, we're going to have to go to stat, arrow over to edit, and enter that data. Instead of taking up the time, I've already done that. So there's 44, 34, 29, etc. All right. How likely would it be to get the above sample if the university's claim is true? Based on the data collected, comment on the university's claim. Well, the university's claim is essentially HO, the mu is 32. There are 32 students. However, you believe there are more. So in this case, 32, greater than 32 students. Now, technically, we're not really running a hypothesis test, but this kind of helps us out. Now, we're having to use the standard deviation of the sample, which lets me know, hey, I'm going to be using a t statistic. So t equals x bar minus mu s divided by the square root of n. Well, you're probably wondering, where did those values come from? Well, you know that I entered the data into the calculator, and then I went stat calc, one var stats. My data, I put it in L1, so second one. And there they are. My sample mean is 32.722, and I ended up with a sample standard deviation of 5.14, and that's my sample size. So we need to draw a picture of this. And the picture goes something like this. We have a mean at 32 because that's what they're claiming. And so until we prove otherwise, that's what we believe. We have a X bar of 32.722. That came from the calculator. It did that for me. I didn't do that by hand. So now that I have that, I can go ahead and plug into the formula. So I want the probability that T is greater because you believe that it's more. And the X bar that we're plugging in is 32.722 minus their claim of 32. We had a sample standard deviation of 5.1427. And we had a sample size of 18. All right, so there we go. And I go over to stat test, and I'm dropping down to t-test, which happens to be number 2. Make sure data is highlighted because we put data into the calculator. The mean claim, we have to type that in, which was 32. Our list is an L1. And oops, make sure we have greater than highlighted. And we calculate, and we go, oh, T equals the probability that T is greater than 0.5958 equals 32 point equals 0.27, excuse me, 0.2795. Well, please notice that when I ran it, it actually gave me my X bar and my standard deviation. So if you wanted to, you could run it and then notice it. All right, so based on the data collected, comment on the universe's claim. Well, first off, that's not that unusual. That's larger than any alpha level, so we wouldn't reject their claim. But we did have a sample mean greater than their claim. So our sample mean was greater than their claim. but our p-value wasn't very small. So their claim is reasonable, right? Claim, let's go, appears reasonable. In other words, we're not going to reject their claim. All right. Yeah, our sample means were bigger, but not substantially larger than theirs. So we don't reject their claim. They're probably telling the truth or close to it. All righty. Appreciate you watching. Hope to see you on the next one. Thank you.